I'm really sorry for this. Yes, bear with me for 2 more minutes. So we were discussing about objects. If I take a generalized term like car, this car is represented, this car is known as a class in computing terms, and every class will have set of objects. So objects will have properties, functions associated with it, and it will have certain application areas. Now, if you take this example of credit card segmentation, where you have run a campaign and you want to see how successful that campaign is, or you want to see if that campaign has increased your credit card spend of the customers, or maybe the campaign has helped you to get new customers. So what you will do is you will segregate your tasks, business tasks, into various objects. Now, the best part here is R, being an object-oriented system, it follows everything that is related with object-oriented system. Best part is it does not force you to strictly follow the object-oriented system like languages like C++ and Java do. There are a lot of things in R which may look difficult, but it is very easy when it comes to its usage. And this is a piece of information especially for the programmers. You don't have to think about complicated logic and stuff. Everything has a shortcut. Everything is defined in R. Let's say you suddenly thought of using loops. After a few days, you'll realize that R does not require loops. There are a lot of things in R. Next 2 days, we will be doing that. We'll be seeing why R is not a traditional language, despite that it looks like one. All right? Okay. So now coming to the objects. Now what will happen next? What will be our next stage is, let's say I created an object for this car class. That object will get every property here which I have listed or created. It will perform every functionality that is listed here. This is what is an object-oriented system is. So this is just for your overall information. Now let's see how do we deal with this in R. So for the beginning, I won't go deep into the OOP system, but I'll give you a push on it. So we will begin with 2 basic questions and try to answer it. And let's see how it is done. Once we are good in that once we have answered those 2 questions, I think 80% of your task is done. This is where 80% of your tasks revolve around. You guys have done SAS, right? So in SAS, how do you get control of your objects? How do you get your objects in the first place? Like if I import data, where it goes? Where does it go? So stuff like that. Why do you have to create a library? If you're performing some operation, where is the output going? If the output is going to the output window, how should I get it so that I can give it back to the client, or I can give it back to my stakeholder? If I'm creating some output which comes in the HTML format, how do I handle it? How it is done? How do I convert it into HTML format? So that was your concern when you were working with SAS. Then entered macros and proc SQL. So where is my piece of information going? Where am I saving my macros? Like what kind of tasks that are happening in my macros? All these things we had to take care about it. Now we'll do the same thing for R. If we know how the basic building blocks work in R, everything will fall into a place. So as a part of your object-oriented system, I want to answer 2 questions. I need answers to 2 questions. So if there is an object, I know that object will store some information. If I create an object for car class, that object will store some information, right? The owner's name, the model, the make, everything. So object stores information. So if objects will store information, if it is true, then I have to answer 2 questions. The first question is, what kind of information is being stored? What kind of information is being stored? The second is, how is it getting stored? These are the 2 questions I need to answer. How is the information getting stored, and what kind of information is getting stored? Now, last class, I know that in this batch there are people who have who have worked with Java. Can anyone answer these two questions? What are these two things known as in technical terms or computing terms?
So an object is just pointing towards a memory location.
No, huh? Okay.
And it's getting the work done, and it's connecting the memory location with that function or the piece of information with that piece of code, and giving it to back to the user.
So
object is just a reference.
So that's what I'm telling. If object is a reference, if object is pointing to a memory location, at the end of the day, it is storing some information for me, right? So in statistical computing languages, I need to know two things: what kind of information is being stored and how it is being stored. That's what I need to know. So what are these things known as technically? No. There are types and data structures, yes. Right. What type of information is data type? What type of data? This is data type. Is it a number? Is it a text? Is it a date? Right?
Generally in Java you have to define the data type, right? You have to give.
Yes. Yes.
But in R we don't have.
I'll tell that. Don't worry about it. So how it is getting stored? Data structures. That's it. So today and tomorrow we'll be discussing these two things. That's it. So once this is done, I think 80% of your tasks are done. How when you are importing data, how it is getting stored. When you are extracting out columns, how it is getting stored. And if I have to work upon columns, let's say I just want to do your first class assignment in R. You have a question like I have a column with launch date and find out cars before that launch date. So how do I handle it in R? So all those things, basically your first three sets of assignments, to be honest. So those things we will be covering here in these two classes, right? Okay. Classroom and online, guys. Any questions so far? Anything that you need to know? Okay. I hope online guys are following and there is no problems in my voice and the video. Is there any problem with the voice and video, online people? Okay. That's nice to hear. All right, then let's start with data types. Data structure is a form in which a particular data is stored. Like there are different kind of structures for different kind of data you talk about. If you are storing a table, you should need a different data structure compared to a situation where you're storing only one information in an object. So that's what this data structure is. We will eventually talk about that. Now here we go. If I talk about generic terms, data can be these. Data can be numbers, text, date, or logical, or Boolean. Now let's see how our language interprets that. In R, every number, any real number is numeric. It can contain decimals, it cannot contain decimals, it can be large, it can be small, everything is numeric. And there is no change in that. So a kind of a relief for the core programming people, like, because there are a lot of things that goes with numbers in those languages. You have int, byte, short, long, float, double, all that stuff. So that's not there in R. It's just numeric. Every number is numeric. Now we have a special case here. We have a special. Any question there? So if you mumble among yourself, that same thing goes into the recording. So I don't want that. I don't want the call to be regulated. If you have any questions, please ask. Okay. We have a special case called integers, where numbers falling with the numbers that fall within the integer range. If you know this, this is the range of an integer. to plus. No, there is no concept of wrapper class in R. Okay, so this is the range of integers. 4, 8, I guess. Yes, including the 0, right? So yes. So any number that falls within this range, without any decimals, that's considered as integers, or in generic term. So in R, what happens is, in some special cases, some functions, or when you're importing few stuff, if the number is very small enough, they get coded as integers. But the thumb rule is, any number in R is numeric. I create a number, it is always numeric. But sometimes it may so happen, if a number is falling within this range and it is very small enough, sometimes R codes that number as integers. But there is no much difference between these two. Even if a number is integer, I can do all the kinds of things that I can do on a numeric type. So, Sonam, what I was trying to tell you is, all numbers in R is of numeric data type. But in some cases, smaller numbers get coded as a data type called integers. But that's not all the cases. That's not a generic case. That's in few specific cases. So if you encounter integers, you don't have to worry about it anything. You can just perform any kind of operation on that. Yeah, you have any question there? You guys, last. Yes. Okay. Small as in any number falling within this range that I have shown on the Excel sheet. So you can pick up any number as an example from that range. Yes, 2147483647 is a small number. Yeah, in SAS it's numeric, yes. All right. Why do we have integers? Even I don't know that. Ross Ahaka and Robert Gentleman aren't replying to my mails, so I don't know that, why there are integers in R. Yeah, seriously, like if everything is numeric, there should not be integers ideally, but there are in some cases you get integers. This is what I have noticed. Like when I'm importing data, sometimes I do get integers, so that's why I need to handle them. I need to consider them as numbers, that's it. There is no special kind of operations or treatment that I have to do to that.
So the way they're stored in the memory, it's the same?
It's the same, yes. So like in Java, if this is an integer, and you declared it as an integer and created something, and you added 1 to this number. So you added 1 to this number, 2147483648. You added 1. What does it become? It's a circular addition, right? It again comes back to minus 2147. So that kind of fun doesn't happen in R. So that's why. No issues. All these things are theoretical. Once we start handling with those numbers, we can very well know about it. I'll anyways give examples once we start writing the code. I will give the examples, but let's just hear some stories and build some sleep. No, seriously. You classroom guys need to wake up, or should I need to turn off the AC? Yes, the third kind of data type is complex. So numeric and integers are for real numbers. Complex is something which contains both real and imaginary part. It's just 0.1% of the analytics industry that will use complex numbers. So when you're working with any kind of scientific data, then there is a requirement of complex number, but as such we don't need it. So nowhere in any case we will come across complex numbers, so we don't have to worry about it. So, but anyways, let's create few complex numbers as well, and let's see how they work. So that's all about numbers. Only thing what is left is, just going into R Studio and typing out and creating few numbers and stuff. So after numbers, after numeric data, I have textual data. Text in R is represented by two kinds of data types. So any text can be character, and text that you import as a part of your data frame will be a factor. So there are two data types that represents text in R. One is character, any generic text, word, letters, alphanumeric with symbols, anything is considered to be a character or a factor. There are two kinds of data types that represent text. So today I will be discussing characters. Of course, we'll see a little bit. Let's see how characters come into picture. But factors I will discuss tomorrow, or maybe in a class when we are starting to work with data. Then we can discuss about factors. It makes more sense when we see factors when we are importing data. So as of today, I won't be discussing factors, but one piece of information you should know is that text, any kind of text, can be either character or factor. So both represent text. Now then I have date. The concept of dates in R or any language is one and the same. In SAS, how it happens, dates get stored as numbers. Number of days from 1st Jan 1960. In R, days also get stored as number of days from 1st Jan 1970. So it's 1960 in SAS, 1970 it is in R. Now, if it is getting stored as numbers, your compiler, SAS compiler and R's interpreter will easily understand that this has to be a date. This so and so number is a date from 1st Jan 1970. This is what our interpreter understands. But every language, you have seen that in SAS as well, every language has a way of representing a date to the user. So if I give 17.3.335 and I'll call it as a date, I'll get slapped. So no one can understand that, right? What is 17.3.35? So 17.3.35 actually is somewhere around November 2016. Because November is almost 17,000 days from 1st Jan 1970. So you have to display that outside, right? So as a part of date, we will mostly see formatting, date formatting. So like you had date 9, date 10 dot in SAS, we have much more easier and interesting things in R. Now finally coming to the most important data type of any language, the booleans, logical data type. So R has a data type called logical, which represents true or false in all caps. Or you can simply code them as T or F. So this is a little bit of introduction to your data types. Let's try create some objects. And store some information in it. First class, I hope we have gone through the operators, right? Assignment, how do you assign stuff and all. We have done that, right? So let's try creating simple objects. We'll put some information in it and let's see what happens. So in data types, I would begin with some functions or helper functions. Of course, that's my zeroth law of R syntaxes, Tanvi. R is case sensitive. In fact, people switching over from SQL and SAS, this would be one of the most important thing to take care of. Most of their errors, initial errors, would be on these. It won't be an issue once you have done any language before, because all the languages in this world are case sensitive. Most of the languages are case sensitive. And again, like I had told you in the last class, you don't have to worry about the indefined functions which are predefined. Most of them are in lowercase. Majority of the functions, let's safely say 70% of R's functions are in lowercase. The remaining functions would be mostly in camel case. Camel case is something where you write the first alphabet of a word in caps. And like if I say my function, so this is what is camel case is. And camel case can contain any special symbol. They allowed special symbol as well. So this happens rarely. This doesn't happen that frequently. And this doesn't happen at all when it comes to base packages. Most of the functions in base packages are lowercase. Right? Okay. So let's see some functions that are related to data types. One is of course class. So that's the most important data type that I will ever need, class. Now then I have certain set of functions. So if I can just list all the data types once, I'm listing that now. So I have numeric, I have integer, I have complex, character, factor, date with a capital D, and is there any doubt, anyone? I can see people mumbling again. That's irritating, man. You're not school kids. We have date, we have logical. Again, come on, be mature, please. So I have a set of functions which begin with this word as dot. Sorry, I'm so sorry, is dot. A set of functions that begin with this word, is dot numeric, is dot integer, is dot complex, is dot character, is dot factor, is dot logical. Now, I think I need to tell what these things do. You can guess it, right? What does it do? It returns true or false. It returns true or false. So it takes object as an argument. It will take one object as an argument. So let's see if I'm using is dot numeric. If x happens to be number or numeric, it gives true, else it gives false. So these are confirmation functions. So I'll begin with class. Class is a function which talks about the data type. And then I have these functions, is dot numeric, is dot integer, and so on. Clear? So we know the functions now. Let's go ahead and create something. But before that, I'll tell you something. Some concept. I mean, like, if you can't understand it, just ignore it. But this is especially for people coming from the core programming background. There is a term called dynamic typing, right? So this is 2017, so we need to get modern, we need to get updated. So there is something called dynamic typing. So what happens in a language like Java, C, C++? If I'm creating a variable, I need to do something called declaration. So I need to know, I need to predict that a certain object needs to store a certain data type. Then I have to declare it. I have to declare an integer, I have to declare a long, I have to declare a string. But in R it's not required. Just take an object and keep going on. R is something called dynamically typed, or dynamic typing. So your assignment of data types is implicit. Assignment of data types is implicit or automatic, handled by the R interpreter. So if I say x is equals to 10 and run the statement, it will create an object called x and it will store 10 in it. Straightforward. This is how it happens in R. If this has to be Java, I have to say int x is equal int x and then go for x is equals to 10. So this is how Java works. I have to declare and then go for it. Not in R. These steps are not required in R. No, actually, I should be sorry. There are no places. So yes, now we have stored 10 in x. At the same time, line number 23, the next line, what I'm doing is, in x, I'm trying to store a string. Now it got overridden. 10 is gone now. Now x has become a string and s is stored in it. I mean not string, I should not use the word string, character. X has become a character. Right? So this is how dynamic typing works. If this had been Java, this should slap me thrice and say this is not allowed. But R doesn't do that, it's dynamically typed. So let's see, let's first start with numeric objects, numbers. Anything is a number. So I say x is equals to 10. That's numeric. Or maybe I just create a sequence of numbers, which we'll do it anyways tomorrow. If I create a sequence of numbers, so that's also a number. So look at it. It's called integer. So I said there are some special cases as well, right? So if we can look at the class of x here, it's numeric. It returns numeric. Likewise, if I look at class of v1, it's something called integer. Both are numbers. And I can do any kind of actions on them. There are no restrictions. So line number 26 is kind of that special case that I was speaking about.
This is the complex one.
Pardon?
This is the complex one.
No. Complex, I have not discussed complex yet. This is simple numbers. Okay, still down, please. Now let's talk about some character objects. Character factor objects or textual objects. What is value stored in V1? V1, we will anyways discuss that tomorrow. They store not just one number, they store sequence of numbers. So V1 is storing sequence of 10 numbers. Or I can say collection of 10 numbers. Yes, it's almost like the concept of your one-dimensional array, which R calls it as a vector, which we will discuss tomorrow as a part of data types. Here just I'm giving an example. We can see that tomorrow in much details. So where you can extract each and every individual elements out of that vector. So you can store a collection of elements in an object. Let's not discuss that today. Next up, coming to character or factor, if I just create any object and store something within these double quotes, okay, we call this R class, So class of C1 is a character by default. Anything that you store is a character, right? But again, like I said, there is a data type called factor, which comes into picture once I import our data. Some data, if I connect to the data and I just import some data, it will give few things as factors. I'm running one command just for an example's sake. We will anyways learn about that function in our later stages. Importing is one of the most crucial part. I will run R's importing statement. I don't want any questions on it, please. I'm just giving this as an example. I don't need anyone asking questions on import statement. I am not discussing import statement here. I'll just run it for example's sake, right? So I'm creating an object called stores. Class wouldn't be string Tanvi. In R, any text is a character or a factor. We have seen that in this case C1, I'm storing some random text, it is getting stored as a character. That goes the same if I have a large sentence as well, it is still a character. No, it's not a sequence of characters. Again, don't mess up the concept of character of Java and string of Java. In Java or Python, we have characters which combine together to form a string. Here in R, if I just imagine something called string, they're called characters in R. Character data type in R. Okay, I'm just importing some data. You need to note this. We will talk about this in much details afterwards. Now I have some data in my R's global environment here. I have imported some data set. Now, if I look at the structure as in the proc contents. So if I go for proc contents of this, so as you can see, as you can notice, you have something called factor. Right? So if I just give you a glimpse of this data, if you just look at a glimpse of this data, the first 4 columns here, the first 4 columns are textual information. What follows next is numbers, right? So first 4 are non-numeric information and they're text. So as you can see in R, this text now is being coded as factors, right? So that's what I said. Text can be, textual information can be either characters by default or it can be factors when you're importing your data. So we will discuss factors on the day when we learn how do we connect to data and all, then we can talk about factors. How do they affect us? This is just to give you an example that there are 2 kinds of data types that exist for a textual information, right? Now, creation of dates, we will see it in details because dates needs to be discussed. We will be spending at least 30 minutes on dates. Is there any specific text categorized as factor? No, there is no specific thing in that. See, what happens is when I'm creating stuff inside R, when I'm creating some objects inside R by my own accord, if that is textual information, it is by default getting character data type. But if I'm importing data, by default I'm getting factor data. That's the only difference in how R is creating factors and creating characters. The character factors, although they represent text, there are a lot of operational differences in between them, which we can discuss when we talk about factors. Yes, Sonam, it's specifically in case of imports. Yes, you are correct. Now dates we can see in much details. Like I said, we'll be spending some time on it. Boolean I need not discuss because one of the most simplest form, logical. So if I happen to store the result of any logical operator or relational operator, it becomes a logical type, right? So if I say 5 greater than 2, the answer is true, right? So if I happen to save it to an object, so that don't worry about it. We can discuss factors when time comes. I am skipping factor for now. So if I happen to store this information in an object, let's say I'm storing that in L1, the class of this is logical. Because logical is something that represents true and false. Now, apart from the introductory discussions, the most important part that we need to discuss as a part of data types is conversion of one form to other. Till now, is there any question that you need to ask or is there any concept that you did not understand? Please let me know. Any questions, classroom people? Online folks, any questions? Don't worry for not understanding factors, let's ignore it. Complex numbers also I won't discuss because it's not required. You can read that from the reading material. Alright then, let's look at the conversion table. OMG. Okay. Okay, I'll give that then. Amit, what do you mean by complex number? Amit, what do you mean by complex number? Okay, anyone can answer. What is a complex number? Something which has real and imaginary part, right? So, if I have, so imaginary part or iota. So I is a designated symbol for imaginary numbers in R. So if I happen to do something like this, if I say n1 is equals to 0i. I mean, this is not an allowed term. This is not allowed. So if I say n is equals to 0i, so this is your complex number. It contains real part and imaginary part. What's the real part here? 0. Yes. Thank God. Thank God actually. So n1 is something called complex number. It contains real and imaginary part. Another example, let's do for it. 3 plus 4i. So this is your complex number. If you look at class of n1, it's called complex, right? And the best part here is I don't have to bother about its operations. So if I have two complex numbers, let's say I want to add them, how it happens, you all guys know it, right? Real parts get added and imaginary parts get added. So in R, you don't have to apply any kind of special logic and all. You can just go on and use the arithmetic operators. So if I call sum I, so that's equal to, let's say, n2 plus n3. Object n2 not found. Okay. So if I just print sum I, so it's 8 plus 7i, right? So they get handled implicitly. This is just about complex numbers. Let's look at the conversion table here. I just want to see like if we can convert one form from other or not. Now, first things first. So as we have seen here, we had a set of functions like these, is dot, numeric, integer, complex and all. They gave the output of those functions is true or false, right? So I have another set of functions which, one second, which begin with the word as dot. So this function is used to convert a data type. Line number 57, if I say as dot numeric, so X is a object from some other data type. I'm just trying to convert X into numeric. This is what as dot numeric means. Now what we are really interested to see whether one form can be converted to other or not. So let's start with numbers. If you take a number, any numeric data type can of course be converted into complex types. Because if I say n is equals to 3, converting it to complex is just 3 plus 0i. But, okay, let's see that. Let's begin with numbers. Numeric. See, when I say numbers and when I say numeric, you have to imagine it as both different terms. Numbers are generic term. Numeric is a specific data type for R. So numeric to complex. So if I say n1 is equals to 10. So if I say n1 is equals to as dot complex n1. So if I say class of n1, now here is numeric, we just convert into complex. Then if I print n1, it is 10 plus 0i, right? Class of n1 is now complex, right? Any questions in this? Online guys, any questions? Cool. Okay. Now you understood this line number 73, right? So this part is converting into complex. This part is converting n1 into complex and again storing it back in n1, right? Yes.
So now in class, n1 value, n1 data type would be complex, right?
Yes. N1 you have changed the data type, right? Next, so numeric to complex is possible. So I'll just put it in green. Achha. Where do you use print keyword and why it isn't used for printing n? See, I don't have to use print every time. So I'm just using print just for, okay. If I say print n1, it will print its contents. If I simply say n1 and execute, it will print its contents. So if I'm just working on R and if I just want to quickly look at the contents of that object, what I'll do is I'll simply select it instead of writing all these things. Let's say I begin here n1. Now at this stage, if I'm at line number 71, I just want to know what n1 is. So I'll just simply select n1. Select the object and press Ctrl Enter. Look at the console. Yes. So likewise, if I run line number 73, now I want to look at the contents of N1. I can simply select that object and press Ctrl Enter. That's it. I don't have to use print statement every time. Right? Like if anyone wants to stick to traditions, you can use that print statement. If anyone wants to act cool, you can go for this. Alright, moving on. So I have put up green over here. Numbers to characters, why not? So I'll put this green in advance. Yes, they can be converted into character. So if I have the same number n1 here, I am putting 10 in it. So if I say n1, now class of n1 is of course numeric. Now if I say n1 as dot character n1, it is now character. Print the contents of n1. It's 10 in double quotes, right? So which means it has encoded itself inside a character type. Can I multiply n1 now with 10, n1 with 3 or something? I can't multiply now because n1 is a character. It won't happen. Non-numeric argument to a binary operator. So if number can be converted into character, it can also be converted into factor. Both represent text. It is possible. Now there is a small Dave, I have told you who has asked it? Neeraj. There's no command, there's something called shortcut. I have given you the mother of all shortcuts. You have to figure it out. So how do you clear console? Control L. And what's the mother of all shortcuts? Seriously. It's Alt Shift K. Comes with usage, but I insist on, just mugging those things up for making your life easier. All right. Number to logical. This is extremely important in your data, converting a number to logical type, especially given the fact that there are certain values in the data which gets represented as zeros and ones. Like, okay, you can think of it like this. Like has driving license, it's a column. I have a column called has driving license. It can be 0 and 1, right? So a process follows in any kind of data manipulation, something called encoding, in which certain textual elements gets encoded as numbers. Like let's say if I have a variable called something called like I said, has driving license. So this is a column. The values should be either within quotes yes or within quotes no. So if I display this data as 1 and 2 or 0 and 1, so 1 for yes, 2 for no, for instance, and 2 for no, or here 0 for no and 1 for yes. This process is called encoding. We can anyways learn about it in data manipulation, or maybe you will be learning this more in your logistic regression, in your BA part. So in these cases, I need to convert an entire column of numbers to logical. So this is where this is where number to logical, logical to number conversion comes into play. So for our example sake, let's take a number again. I say n1 is equals to 100 now. Let's increase our value. So if I just try to convert this into logical. So if I say n1 is equals to, or just simply I'll print as dot logical N1. What would be the answer? Any electronics people over here? Anyone from electronics and communication background? Online people? Anyone from electronics background? Okay, anyways. So you people can answer this question. If I have a number and I say as dot logical that number, what will this give? Yes, it will give true. I'll explain you why. And I think most of you would also be aware of this. This is a very basic principle with which all your devices are working. What happens in your circuits is if any voltage is flowing through it, it is considered to be a true gate. Any voltage flows through it is true. No voltage is flowing, it's false. And that voltage can be anything. A small, a large, like if I have 5 volts range, it can be a 2 volt voltage, but still something is flowing. It can also be a reverse voltage. It can be minus 2 volts or minus 3 volts, but there is some value over there. There is some voltage over there. So if I have any value to an object, any number in an object, I'm just trying to convert that into logical, it is always true. Any number except 0 is true. Had N1 been minus 100, then also it will be true. Now, if I take example of N2, N2 is 0. If I convert this into logical, it will be false. So 0, if I convert into logical, it will be false. So yes, numeric to logical is possible, but I'll just put this in a light green because there are some conditions that apply here. Your original data is lost, right? If I say N1 is equals to as dot logical N1, your N1 will no longer have 100 or minus 100 in it. It will have true in it, true or false in it. The data is lost, but yes, conversion is possible. It's almost like, operation successful, patient is dead. Right? Okay. Numbers to date, yes, it is possible, but we will discuss that once this section is done. We have to have a detailed dates with date. So we'll have a detailed section on that. Now complex I'll not discuss because we'll anyways won't use it. So I'll just mark it as we're not discussing this. Let's talk about characters. Character to other type conversions. We had just converted a group of numbers to a character. Now let's see the reverse of it. So can I convert a character to number? N1 in my global environment is still showing as 100, minus 100 because I have converted it but I have not stored it. So if my line number 90 has been this, N1 is equals to as dot logical N1, then the value would have changed. You can notice the value change now. So please keep in mind, whenever you guys are importing data or just trying to change the data types of the columns or you're doing something on anything, make sure that you're saving it back. You're assigning it back to some object, or else everything will be gone. It will merely print on the console, but it will not save it. Character to number. Can this conversion be possible? If I say S1 is equals to let's say class, our class. I convert this into numeric? All right. Let's see. As dot numeric. Yeah, it gives ASCII. Wow. Somebody said that. Excellent. Maybe on basis of ASCII value. Don't you feel that you're using your brain more these days? So see, if I take a character object, S1 is a character object. If I try to convert it into numeric, it will not do it. It will simply print NA for not available. NA is something which represents a missing value. So conversion has not been done. I mean, like, you lost your data. So this conversion is meaningless, right? This is also like something, this is not throwing you an error. This is giving a warning message, but your data is gone, right? Again, this is also somewhat like, operation successful, patient dead. So numeric character to number conversion is not possible, right? Agreed? Agreed. I repeat my question. Character to number conversion is not possible, right?
Possible.
Let's take another example. I'll take S2. So S2 is a character, right? Can I convert this into number?
Yes.
No, it will give NAs, man. It will give, yeah, even in this case also, my answer is yes, I am converting it into character, but I'm getting NAs. What about this? So see, logic here is, S2 contains, no doubt, S2 is a character, but it contains numbers. The data is numbers, stored as text. So yes, you can bring it back to its original form. Why did I do as dot character? It's as dot numeric, sorry. When I try to bring it with its original form, it is possible, yes? So I can say N1, for instance, N1 is equals to as dot numeric S2. That's it. So N1 will be now the numeric equivalent of the textual data. Clear with this? Okay. So character to number conversion is possible, but conditions apply. So this goes in light green. Same goes for complex. I can use as dot complex and convert it, but it has to be numbers encoded with it. So character and factor, they are like twin brothers. So a character can be converted into a factor. So it's a yes over there. Don't worry, I'll share this Excel sheet. I have always shared this Excel sheet with everyone, so you'll get it. No need to take explicit notes, especially the classroom people. Character to logical. If we have alphanumeric data, character number possible only when string contains digit and not R class, always. Yes, Sahil, you're correct. In case of S2, yes, this can be converted into numbers, not in case of S1. So any alphanumeric character cannot be converted into numbers, but numbers within a text can be converted back into numbers. I didn't get your question, Shubhi. Please, can you repeat it? No. We don't have types of NAs. R does not discriminate. So missing is always a missing. Oh yes, this question comes from SAS. Like SAS has dots for numbers missing value and blank spaces for character missing values. Okay.
Yes.
Okay. Not an issue. Now let's try to convert character to logical. Now this does not work on the basis of principles what we have seen for numbers. If I have some numbers, I can just convert into, I can get true or false, but not in case of characters. So if I take S2 for instance, S2 is this, okay, not S2, S1 for example. So if I say as dot logical S1, so it's NA. It's not possible to convert it. So that's why I put blank. Character to date, of course it is possible, and of course it is the most important discussion that we'll be doing on dates. No issues, Sanat, it will last for 20 more minutes. Thanks for the concern. Now, the same yes or no status I can put for factors, because factors are also representing textual information. They're exactly like characters. Like I said, they are twins. So factor to number is possible only if it contains numbers. Same goes with factor to complex. Yes, factor can be converted into a character. Factor cannot be converted into logical. And yes, factor can be converted into a date. Now coming to logical values. Coming to logical values, if I take some logical elements, I have L1 which has true in it, and I'll just explicitly assign some values. L2, let's say it is false, right? The two values of logical. Let's try to convert this. First logical, two numbers. My hands are too big for any keyboard, man, seriously. So they need to get kind of bigger editions. Okay. If I say as dot numeric, again numeric L1. So L1 is true. As dot numeric L1, no need to guess at what it will be. What it will be? L1 is true. If I convert it into number, it is 1. L2 will be 0. That's it. And this is a little bit interesting. Logical to character. So L1 is true. If I say as dot character L1, it prints true within quotes. So look at the difference. L1 here in line 121 and line 122. Look at the console, please. As dot character is true within quotes, and this is normal. So if I convert to character, of course it will lose its Boolean properties and it gets converted into a text. So TRUE is a mere text, not a Boolean type. Two factors, yes. If I can convert something to character, I can also convert that into factor. Logical to date, it's not possible. So if I say today is true, what does that mean? Nothing, right? Pardon?
Why is it green?
Which one? I haven't put any green. So logical to numeric, yes, you'll get ones and zeros. Logical to complex, yes, you will get 1 plus 0i and 0 plus 0i. Logical to character, yes, you'll get the entire string encoded. Logical to factor is also yes, but logical to date, nope. Date is something which is very good actually. Date can be converted into any text. Any questions so far before we get into dates?
Character to date, it should be number, like real string cannot be converted to date.
A real string?
REAL in a string.
Achha, no, that cannot be converted. Okay, character to date, right? Character to date.
It should have numeric string only.
Okay, I'm so sorry. So character to date, there are certain conditions apply. So I'll put it in light green. Same goes with, yeah, I'll put this in light green, sorry. Yes. A character can be converted to date, but there are certain conditions applied to that. Of course, they need to be in a proper date format. Not all textual data can be converted to date, right? So I can't say today is our class. What's the date today? I can't say today is our class, right? So that's what it is. Okay, let's get into dates then. We'll talk about it. Let's first, we'll start with the function that can get us a date. So let's start with a function that can get my current date. So it's sys.date, SND capital, sys.date. So it gives me system date, present date in a format, year with century, month number, and the day. So this is my default format. That's the default date display format. So just save it in a variable called today. So I will have this. The class of today would be a date. Yes. So if I just take this, like print this, you can see that it has been printed in this format. Year with century, month number, and day. So the default display format in R is technically known as unambiguous string format. So this is the default format, or also known as unambiguous string format. So this is how dates are in R. And like I said, dates are internally stored as numbers. If I just try to convert today, this object called today, to number, you'll get to know why. So if I use as.numeric to today, so you'll get a number. So 17264 is number of days from 1st Jan 1970. So that's what it is. 8th April 2017 is 17,264 days from 1st Jan 1970. Any questions in this? So that's why I said dates can be converted into numbers. And yes, I'm not losing any data. I'm not losing any. Let's call this number as date underscore num. I am not losing any data. Let's see it later on. We have converted a date to number. Right, clear? So this is all about dates. Now, till here it's all butterflies and rainbows, but when I start importing data, that's when the problem comes. So SAS is a little bit generous enough to understand, like if my data is coming from Excel, SAS will try to match with any of the existing in formats. If your present dates if the data present in the dates column match any of the informats, it gets coded as the respective ones and your variable remains as a date format. Doesn't happen that with R. That thing doesn't happen in R. R is not that generous enough. So what happens while importing? Problem with dates while importing. So SAS will try, if it matches any informat, it gets a date. If not, it will convert that into a string, straightforward. Right? You must have noticed it by now. Import any date, you'll get it as character type in SAS. If it matches, like if your original data matches any of the informats, try importing an Excel sheet with proper info, any of those informats into SAS. It will clearly get it as a date column. So SAS will try, but R won't. Any date column is imported as character type. This is what happens. This is the problem actually. So I need to overcome that. So simple thing. In these cases, every time we convert such columns back to date. So if I have a date, I need it in date format. It's easier for me to match. It's easier for me to calculate the days difference if I have all dates. I can't do that with numbers. So if I have dates, I can group by and I can find out leads and lags in my data. Cumulative sum I can find out. But this all will happen if the variable present is in form of date format. If it is in character, I can't do it, right? So I need to convert it. So fine, let's try doing it. Let's take some dates. I'll create some character objects. Let's take that and just try to convert it into dates. So first object, I'll just call this as date1 or date char1. I'll store the standard date in it, like let's say 2017 10/01. So if you look at the if you just compare it with sys.date, this is almost like 1st October 2017. This, as a human, I know it, but our compiler, being a robot, the date char, the class of it is character, not a date, right? Okay, let's have the date char1. Date char2, I'll just put some other date, the standard date which we know. Let's say I want to put 11th November, so 11/11/17. Number 11, 2017. Or I'll say date char2 or date char3, I'll say, third variable, third example. I'll put hyphens here. So this is September 12, 2017, let's say. 16? Yes, I changed it. Let's say I have date char4. Yeah, let's write it in a good format. April 13th, 2017, right? Let's take these 4 examples for the beginning. And finally, date char5, I will just take it as today's date is 2017, 8th April, right? Okay. All right. So let's begin with date char1. Date char1 happens to be a character. We already know it. How do we convert it into date? as dot date. So I'll just use a variable name called date1, for example. I'll use the variable name called date1. So date1 is equals to as dot date, the capital D, date char 1. So this is simple and straightforward, because date char 1 happens to be in this format. If I use as dot date, I can clearly get a date format from that. See, although they're displayed in one similar format, but the data types are different. Date 1 happens to be a date type. Date char 1 happens to be a character type. Although they're displayed both in the same way. Clear with this conversion? Now let's try to do that with date char 2. Now if I run line number 155, okay, I'm so sorry. Okay, if I'm running line number 155, so look at this. Something weird has been displayed on the screen. So this is not what I'm expecting, right? So this is not something which I'm expecting. I'm expecting that it should convert date char 2, which contains 11/11/2017, which is supposed to be 11th November 2017. R should ideally print it as 2017/11/11, but it's doing something else, right? Now here comes the kind of informats in R. So there is nothing called informats in R. What are informats and formats of SAS? They are predefined. Certain things are predefined, right? Now R, not everything is predefined. Now let us see. Please pay attention and let us see how it works in R. The main underlying principle behind dates in R is the date components. Date components as in day, month, year for the beginning, extended to the time objects like hour, hours, minutes, seconds. These are the components of date time, and first three are the components of any date object, of course, right? Or I can also call it as day name, a day of the week, Monday, Tuesday, and all, right? So this is the basic format in which R is dividing your date. I'm not getting it. What you're not getting it, Sonam? So if you write a date will have those components, right? A date will have day, month, year, and day name. Day name as in Sunday or Monday or so on, right? If I just extend that to a date time object, like if I also include time, time will have hours, minutes, and seconds, isn't it? Right? So that's it. So R will divide these conflict. If R has to understand a date, R will first divide dates into these kind of categories first. Now, once it is divided into these components, dates in R is divided into date components first. Once you're dividing that into date components, every date component is identified by a symbol. Every date component is identified by a symbol. So let's see those symbols. What is that? So these are the symbols that I was talking about. If I have a date called 5th March 17, so this is how Excel is printing it. I want you guys to pay attention. 5 is the day, Mar is month, and 17 is year. Right? I have the three components, day, month, and year. Now, a day is represented by a string called %d. See, again, I repeat it, there are no fixed or predefined formats in R. So there is nothing like formats and informats in R. It all drills down to dividing your date into components and identifying those components by a string. So I divided my date into day, month, year, and day, and I'm just identifying that with a certain string. So day is represented with %d. While we are doing the examples, these things will be much clearer to you. But for your information, days are represented using %d. Month, if it is 0 to 12, if it is 1 to 12, it is %m. Jan through December, the month abbreviations is %b. And if I have to write full month name, it is %B. Alright? And year with century is %Y. Year without century is %y. Let's take this piece of information for the start and let's try doing some stuff in R. Okay, now let's get back to our example, date 2, which was giving an error. Now, when I'm converting a certain character to date, it's my task that I identify the components and then convey that to our interpreter. So, okay, this is a root term, I'll call it user. So when you're converting a character to date, the user should identify the components and convey that to our compiler. So let's begin with date 2. Online people, are you all able to hear me? Okay. Now let's look at date 2 or date char 2, which is the character which we are looking for. Let's look at date char 2. So it's 11/11/17. Can you please identify the components for me? So this is day. Let's call this as month and this is year. So if I have to identify it, somebody is mumbling again, man, seriously. This thing actually sucks, seriously. If you have anything to ask, please ask me that. It's so immature of you. Okay. So this part here, yes, thanks for spoiling the suspense. This part here is the day part, so I'll call it as %d. The next 11 is %m followed by which y? Small y, right? Small y. Are we done? Yes, we are not done yet. We have identified the date components, fine. We have not yet identified the separators. So the separator here is, yeah, okay. So \. And remember, I don't want any arbitrary spaces in between. This here on my screen is a very wrong interpretation of the object that I have. I need not have any arbitrary spaces. It has to be exactly like this, the one which you are trying to convert into date. Right? Clear with this? Now, let's make use of it. So as.date function has an argument called format. So to the as.date function, to the format argument, I will pass this string here. That's it. That's all. Now if I run line number 175 and look at the component of date 2, yes, I will have 2017 11 11. And class of date 2 is date. Any questions that you need to ask? I think this will be more clear when we'll do the next example.
Sir, when you said that there are no predefined characters,
I said there is no predefined formats.
Okay. So like we define those %d, %m, %y.
No, these characters are predefined. These characters are predefined, yes. See, instead of defining the format, I just broke it down and defined the individual elements, not the format itself, right? Okay.
But then there is default format, right?
Okay, default format, yes, it is called unambiguous string format, yes. So, see, you can't go everything arbitrary, right? There has to be at least one thing which has to be standard. So, SAS, there is nothing called standard date format. SAS, it has to be something what user has inputted and converted it into date 9, date 10 formats, or it has to be number internally, right? In R, it is the standard unambiguous format. Apart from that, there are no formats of dates in R. Everything else that you type in is a string. Now, let's take date char 3 for example. I think it will be more clear if you do that example now. As dot date char 3. Now, can you help me out? 9/12/2017, which is 12th September 2017. So 9 is okay. 9 is %m hyphen %d hyphen capital Y. That's it. So I'll say format is equals to this, right? It's done. Date 3 is 2017 September 12th, and needless to say, class of date 3 is date. So the process that we are trying to do is convert any character as in anything that is input from the user to a format that R can understand, right? Clear with this? Let's do the remaining examples as well and close it. We had date char 4 and 5. Why capital Y? So this is the reason. Capital Y because it is representing year with century. So that's why capital Y. Now, what I will do is to avoid any kind of further confusion, let's look at the place where all this kind of information is given to us. So if you happen to open the help for this function called strp time, so then it gives you the date time conversion. One second. So strp time gives me the date time conversion strings here. So here we go. So you can just open the help manual and look at it whenever you are trying to convert any date. %A and %A for weekday names, %B abbreviated month name, this is what we have used. %B for full month name, yes. So on, it goes on. %D we have used day of the month as decimal number. So you guys can go through it and just play around it. Mime, that's a very good question, but I wish to remind you that here in this case we have picked up a user's format, a format which the user likes. We picked it up and converted into a date which R understands. So this is what we are doing. We're converting a date into we're converting a character into date. The thing that user understands is a character. The thing that R understands is a date format. Now let's do for date 4. So how do we do it? So no, the full statement of course. Date 4 as dot date char 4 format is equals to, yeah, go on, % capital B space %small d comma space % capital Y. That's it. So date 4 is now converted into R date and of course class B date. Not date char 5. Let's try doing this. Date 5, date char 5, format is % capital Y, no space, % D, % yes, M. Okay, this is not April 8, this is August 4th. So it's %M and %D, right? So this is what it should be, right? But why it is throwing an error? Just remember, what I'm discussing now is converting characters to date. Is date 5 a character? Date 5 is numeric, right? So error because input is a numeric. Input is a numeric object. So that's why you have this error. So it says origin must be supplied, right? So again, you may find a situation where your date is coded like this in your data, and when you import it, the column becomes numeric. So this is the place where before doing any such operation like this, but we are very much sure that this is representing a date, a format in which we can understand. So I have this year, I have a month, I have the day, right? So in this case, what we will always do is, we'll first convert it into character. We'll first convert date char 5 into character, and then we'll convert it into date. Look at the statement here. Is there anything that you need to ask? No, right? Any questions here? So now if I happen to run this is not an error. Of course it won't be, and date 5 is 4th of August 2017. Yes, it can be written in the same line, of course. Okay, I'll definitely repeat the statement. Look at line number 192, Ayush. I have date char 5 and class of date char 5 is a number, it's numeric. So if I'm using this kind of a conversion statement that I have done for the previous examples, this will give me an error because it expects some other level of input if I'm passing out a number. But as a human, I know that this is something that is representing date in form of date components. Even though it's a number, it's representing the date in date components, not in number of days. So my components are here clear in front of me. This is my year, this is my month, this is my day. So in this case, what I should do is date char 5, because it is number, I need to convert that into character first. So this is what I'm doing in this line. I need to convert that into character. Once that is done, I will be passing it on to as.date function here. Then it will give me correct outputs. Clear with it, Ayush? Okay. Can we convert numeric dates? So why didn't convert numeric to? We can convert numeric to date. So why did it convert? Acha. Again, the reason it did not convert Mayank, because format argument, if I'm giving a format argument, this means that R will be expecting some character over there. Then only it will accept this format argument in the first place. My input should be a character. So that's the reason why I put this heading as converting character to date. I didn't say the converting any object to date. I didn't say it, right? I said converting characters to date. This is how it is done. Now what we'll do is, let's convert numbers to date. So just before, what we had done is we had converted today's date into a number, right? So date num, or what is the variable name? I forgot. Here we go, date underscore num. Okay, I'm so sorry, I didn't create that. So date underscore num here. This is 17264. The class is numeric, of course. Numeric. I need to convert that into date. So in this case, I'll call it as date 7, for instance. So I'll still use the same as.date function. I'll still pass the numeric object as an input. The only difference here is, instead of format argument, I'll be passing something called origin is equals to. How smart is RStudio? You can see that when I was passing a character to as.date function, date char 1, this is a character, right? So when I press tab, it gives me format. But when I am passing out a numeric object, passing in a numeric object, it gives me an argument called origin. RStudio can help you learn R literally, actually. So every date, every numeric inputs to as.date function should have a base day. It should have a base date. Now again, R will not take anything by default. If it is a number, R will not try to take anything by default. So base date as in the day from which you are trying to count it. So 17264, we had counted it from 1st Jan 1970, right? Now I need to write 1st Jan 1970 over here. How do I write it? 1970 -01 -01. This is the standard unambiguous format. So this is my origin. So if I convert this into date, yes, there is no syntax errors now. And if I happen to print the contents of date 7, I have it. Today's date, 8th April 2017. So I had converted this is date to number. So I got 17264, and 17264 I'm just converting that back into date using the argument called origin. Yes, if I'm not using origin, let's see what will happen. Now let's say in this case I'm not using the origin. So it will give an error. It says origin must be supplied. Right? Now you must be really careful with the origins, and it needless to say, like if you are having any data coming from SAS, if you have any data coming from SAS, your origin must be 1st Jan 1960. If you have this date numbers coming from SAS, it has to be 1st Jan 1960. Everything else in this world is 1st Jan 1970. Because in the 70s, things got standardized after GNU and Linux came into existence. Every system is now standardized into Linux. It can be Hadoop, it can be Apache Spark, it can be any server, it can be MySQL, Oracle. Everything is Linux based. R is also Linux based. So we have sorry, no, I'm so sorry. It's not Linux, it's C based, C++ based. Linux also is C++ based. So everything is 1st Jan 1970, right? Except SAS and SPSS. And now let's do the reverse part. Like we have converted strings and numbers to date. Let's do the reverse. If we have a date format in R, how do we convert it into a format what we need, right? A format in which you can display it elegantly, right? So let's take a date. Let's take today's date. So say today is equals to sys.date. So this is basically converting date to a presentable character format. Now here, to do this, I will use a function called format. In that case, it was as.date. In this case, it is format function. The syntax of format function is very simple, yet a little bit confusing in the beginning. Please make a note. The difference between as.date and format. Format takes an X as an argument, any object, any arbitrary object as an argument, which has to be in date type. My next argument to format function is format. Remember, format here is an argument to format function. Clear with this, right? So this is the syntax. Now, there is a slight difference in this format of format function and format of as.date function. Just rewind for 30 minutes. The format in as.date is a thing which human has identified that a certain character has certain date components, and it is conveying that to our compiler. Now here in this case of format function, what the user is doing is, the user already has a date. It is trying to convey the R compiler that please get me a character in this given format. So here format will print a date in the format in which I have specified in format function. Clear with this? So my date object gets formatted to the supplied input to the format is equals to argument of format function. The creators of this function should have been a little bit sensible not to name both argument and function in the same way, but they are not. But we'll be a little bit careful and let's not get confused. I hope this thing is clear for everyone online and classroom. Clear?
Can you please come again?
Okay. What was format argument doing in as.date? Converting, right? So basically format is a human as a user, you are identifying the components and conveying that to R. Here in this case, what we will do is we will give the same formats, the %D, %B and stuff. What it will do is it will convert the given date into the supplied format in reverse. Okay. Now let's take today and let's try to convert it in some formats. So if I call it as today underscore display 1. So what is the default format in which this gets shown? So sys.date or today is in this format, year, month and day. So I'll use format function. In date function we had defined it for R to understand. Yes, exactly. Now in format function we are using for the user to understand R's date. You people are creative, man, seriously. So format, my argument is today, and to this I'll pass on a format argument. So I'll say format is equals to, now let's say I don't understand this, so I'll want it as something which I can understand. %D space %capital B comma %capital Y. Right? What will be the output of this? So today underscore display 1 will be 08 April comma 2017. Class of today underscore display 1 is a character. Right? Clear? So you have your data, you have taken your data, you felt that there is a column which represents certain dates. Because that column got imported as character, you converted that into a proper understandable date formats, and then yes, seriously. So and then we did some operations like calculating time difference and stuff, and finally you again felt that you needed to display it in a well formatted way. You will convert that back into character using format function. This is the cycle that you have to follow. That's it. So let's do it in one more format as well. So I'll call this today display 2. I'll use %D, %B. I'll also add something called %small a. The right. So feels like a hot-headed British person. See? can pass anything to this format argument. The only thing is that the %d, %b should never be changed. You understand now what it represents. If you need to know more, or if you need a quick reference of it, you can always look for the help for strp time function. You can get the entire documentation for the format strings here if you just keep scrolling down, right? We cannot do any mathematical operation on this formatted date. Yes. So we cannot do any kind of mathematical operations on these following objects that I'm trying to tell you now here. Date char 1 till date char 5. These all are characters. No date operations on these. Today underscore display 1 and 2. No date operations on these. No date operations on these. Clear with this? Okay. Now again, just rewinding back to converting a given string into date, which is most frequent operation that a person has to do. For this, I have a very beautiful package called Lubridate. I'll give you the documentation of Lubridate and its functions. But as of now, I'll discuss only few functions of it, only the conversion part of it. So let us discuss conversion of characters to dates, right, using Lubridate. So Lubridate is a package. Again, this is one of the packages that I have used most frequently in my projects. So ggplot, dplyr, Lubridate, Plyer, Shiny, R Markdown, and a lot of it, Plotly. So this is one of them, Lubridate. So let's take those date chars again. Date char 1. Let's print everything all together first. Okay. So just for convenience reasons, I'll convert this into character. What has happened? Yes. Of course, right? This is making more sense now, right? We know why we are converting this in character. Now, the Lubridate gives you a set of very beautiful functions like these. I have a function called YMD, stands for year, month, dates, DMY, MDY, and DMY, YDM, right? That's the only remaining, right? They're the four things that R Markdown, Lubridate gives you. They're the four functions. Now what we'll do is, yes, as a user we have to again identify the components, but we can get rid of the %d, %b stuff if you feel that it's still difficult to remember them, right? Let's take date char 1 for example. It says 2017-1001. So it is in which format that Lubridate can understand? Which format is this? It's year, month, and date. So it is in YMD format, right? So let's write it down to avoid confusion. Let's write it down here. So date char 1, the result is this, and it is in YMD format. Yes. Similarly, date char 2 is DMY format, right? 11-11-17. Date char 3. Yes, what is date char 3? Which format is it? Yes, so MDY format. This is also MDY, right? MDY. And finally date char 5 is again YMD, year, month, date. So it is year, month, date, right? Let us use these functions to each and every character and see what happens. So if I take datechar1 for example, it is in YMD format. So I will apply YMD function to it. So I'll call it date1 underscore LD, LD for LubriDate. So I'll say YMD datechar1, right? If I run this and print the components of date1 underscore LD, it is in the R's date format. And if I look at the format, of course, yes, let's confirm the format. It's the date format of R. Date1 underscore LD. Yes? Easy conversion, right? Easy conversion of your character to date, right? Let's do that for datechar2 as an example. No, why did I do as.add? It should be class. Yes. So let's do that for datechar2. I'll call this as date2 underscore LD. This is DMY, right? So DMY datechar2. Now let's look at the contents of date2 underscore LD. It is in standard R format and class of date2 underscore LD is of course date. So similarly datechar3 is MDY datechar3. So datechar3, which happened to be a character, is now converted into dates. This is much more easier than the base one, right? Instead of you specifying the formats, just identify it and pass either of those four functions. I really hope you would be able to do that, right? Any doubts in LubriDate package online, guys? Any questions that you need to ask online people? Mayank, Amit, Arjit, Sahil, Harshit, Manoj, Sonam, any questions? Now, I really want you to go through the LubriDate functions, which I will be giving you today. If things get uploaded, I want you to go through it. So you can extract the months, you can extract year out of it. Yes, you have to download and install LubriDate package if you don't have it. Or like I said, you can just snatch it from someone who has already installed it. Or you can bribe them, man, come on. Feed them chocolates, donuts, give them, they'll do it for you. What was I discussing? Yeah, I'll share this code files. Of course, I'll share this code files. Don't worry about that, Manoj. So yes, you can extract your year out of it. Like let's say you have a date, you have certain dates, and somebody asks you to find out time difference in years. It's always easier to extract year and then find out the difference, right? So please try doing it using LubriDate package. It's much easier than anything else.
Is there nothing like EDF function of that?
No, we have diff time. Yes, it's a good question. To calculate time difference, we have a function called diff time. All right, then let's discuss this. Not an issue. So let's take two dates. We have date 1, for instance. Yes, and let's take date 4, which is 13/4/2013. Yes. So if I use this function diff time, so my first input is the time one, or which is my date. Let's say the bigger date is date 1, right? Time 2 is equals to date 2. Oh, sorry. Units. Units is an argument which will specify which kind of difference you need. First, let's not specify anything in the units. Let's see what is the default output of this. So it gives me by default in number of days, time difference of 171 days. This is what is the output of the statement, right? Now let's do this. If I say diff time, help of diff time, time difference or intervals. Fantastic. So if you look at it, the units argument can be auto, which is days. It can be seconds, minutes, hours, days, and weeks. So if I need the time difference in hours, then I would say diff time, same function here. Know this term, right? Java people would be more obsessed with that actually. Function overloading. So units within quotes, I'll go for weeks, for example. So I'll get time difference in 24.4 weeks. Yes? Better than year diff, right?
The option of standardizing the year 36.
Whatever it is. SAS. All right. So that's it. Let's close for today and let's meet tomorrow.